Many years ago, a group of people got together and they wanted to start a community that was self-sufficient. They wanted to live on their own, away from everybody else, and to provide everything that they would need themselves. So they found an island out in the middle of the ocean, far away from any civilization, and they built their colony there. They produced everything themselves, from their food to even their clothes. If they wanted a shirt, they would grow the cotton, they would weave it into a material, and then they would make it into a shirt or pants, whatever they needed. As you can imagine, they didn't have cell phones or even automobiles because the island was small and it wasn't something that they could manufacture, so they just didn't have that in their community, which they didn't need it. It was pretty small and close together. One year they ran into a problem. The rain didn't fall. There was a drought, and they were prepared for such a thing, and they used some stores that they had set back. They had set back plenty of food for a time just like that. At the beginning of the second year of the drought, they began to grow concerned as they saw their supplies dwindling, and they knew that they couldn't go on a whole lot longer without replenishing their stores. So they got the greatest minds of their town together. They're great thinkers, they're scientists, they're engineers, to solve this problem of the drought. By the beginning of the third year of the drought, when they were nearly out of food, their great thinkers had a solution. And what you see next to me is a smaller version of their Drought Stopper, and that's how they fixed their problem. But what we see here is a black box. It looks like a cardboard box on the outside, painted black. There's a funnel in the top and a plastic tube sticking out the front. I do have an empty container here that I'm going to catch the water so we can keep track of how much is going in and going out. And here we have an Erlenmeyer flask with 250 milliliters of water, except a little bit I just spilled out there. I'm going to pour some water in here in just a moment, and we're going to see what happens. Now, before we pour it in, and then we're doing something scientific here, I want you to think about maybe some things that could happen. Well, you could pour the water in the top, you might say, and the water might come out the tube. That's a real possibility. What else could happen? We could pour the water in the top and maybe it won't come out the tube, but maybe this is a cardboard box. Maybe it starts coming out of the corners of the cardboard box and make the whole box soggy. I have had that happen before. Third option is we could pour it in the top and nothing could happen. It could just sit there and do absolutely nothing. And maybe you can think of a fourth option of what could happen. But it's always good to have some kind of expectation of what you think might happen before you begin. So I've got 250 milliliters here. I'm going to go ahead and pour in about 100 of it, because sometimes it doesn't quite take all of what we have here. There's about 100 milliliters. Oh, there it goes. So here we have, so we use about 100 milliliters of water there out of our flask. I'm going to go ahead and empty this out because we're done using. We just use this as a little bit to start in. Well, the Drought Stopper fixed their problem, and they never had a problem with encountering a drought or situations where they didn't have enough water. So I want you to be thinking about, now that the water is coming out, we'll go back to just the real basic stuff. So we poured the water in the top, and yes, we were right, the water did come out the tube. Now let's think about how much water can we expect to come out of it. We put in 100 milliliters. How much water might come out? Well, in a perfect world, we might expect 100 milliliters to come out. That would make sense. Pour 100 in, get 100 out. You might say, well, there might be some spill, or there might be some that doesn't quite make it through, maybe get stuck inside the box, and so there might be 90 milliliters or even 50 milliliters, something like that. You might say to yourself, what numbers might not be expected? Well, you probably wouldn't expect anything over 100 milliliters. That wouldn't make sense to pour in 100 and get over 100 back out. But, let me catch this here too, but that's exactly what we're seeing here. The 100 milliliter mark is right here, and I'm going to go ahead and pour that in to there. That's actually a little bit too much. So we poured in 100 milliliters, which is this, and we've already gotten out more than 100 milliliters. Well, now you can see why it's called the Drought Stopper. Pour in 100, you get out way more than 100. That would solve any drought. you'd have as much water as you possibly would need in that situation. So I'll pour this back in here. Push this forward. So this should be unexpected. We pour in 100 milliliters, and we're obviously getting out way more than 100. Right now, you should be saying to yourself, "Well, that probably shouldn't happen." And you're absolutely right. In science, there's something called the law of conservation of matter, and that law is pretty standard. It is standard throughout the universe, and it says you can't take nothing and create something like matter, like water, and you can't take something like water and just make it go away completely. It can change forms. It can even be torn apart into smaller pieces like Legos and then reassembled into different things. Same thing happens with plants. Plants take water, which is H2O, 2 hydrogens, 1 oxygen, and carbon dioxide, which is CO2, 1 carbon and 2 oxygens. And using the power of the sun, it takes those 2 molecules, several of each, one, and disassembles them and reassembles them into a new molecule called glucose. There are some pieces left over. There happen to be oxygen. So the plant, in the process of making a sugar molecule, a glucose molecule, throws out an oxygen as well. That's why plants oftentimes are known for making oxygen. As people get that food from that glucose molecule from the plants or other animals, we take that into our body, but we can't unlock the power that's locked inside it. We need that heat, that energy that's inside of it. And so we breathe in oxygen, attaches to that glucose molecule. It then tears apart, releasing the energy from it, and we end up again with what we started out with. It's reassembled into the 2 base components that it started with, which is water and carbon dioxide, and we breathe out that water and carbon dioxide as you know. We're up to a little over a liter, which is a little over 1,000 milliliters. We put in 100. We've gotten well over 10 times that amount, and it's still going. So the law of conservation says, hey, this isn't supposed to happen. That's right. Let me tell you a few things that are not inside this box. Number one, what's not inside this box? There's nothing inside that's too overly complicated. There's not some special fission fusion reactor that bends space and time and the particles and matters of reality and things to create this water. If you look inside this box, if you were to look inside, there wouldn't be anything special. It wouldn't be like, oh, I can understand everything that's in there. So there's nothing overly complicated inside the box. Second thing that's not inside the box. There's nothing magical going on here. You may have seen TV shows with magical elves and wizards and things that they do all those kinds of stuff. There's no magical elf inside this box with a wand. The water doesn't wake him up and he suddenly waves his wand and starts making water. There's nothing going on here. You may have heard a story about Jesus and his apostles that fed 5,000 men and their families over just a few loaves and a few fish, and at the end ended up with 12 baskets of leftovers after they fed everybody. That is pretty incredible. That's a miracle. There's no miracles going on in this box. Okay, so we've ruled out overly complicated, we've ruled out magic, and we've ruled out miracles. None of that is happening here. At the same time, we know that we can't be creating something from nothing. Hopefully by now the wheels are turning in your brain. You're thinking, I think I've got an idea of what may be happening inside of here. Your assignment at this point is going to be to take a piece of paper and draw a box toward near the center. Draw a little funnel on the top if you want, a little tube sticking out the front, and then draw for me on the inside what you think might be going on inside. Think about what happened. Water was not coming out at the beginning. It didn't start until I poured the water in. So please don't, here would be a bad design. A big bucket of water with a tube coming out of it. If that was the situation, water would be coming out already. So what started the water dripping, okay, was me adding water to it. Okay, so here we have 2 liters, so 2,000 milliliters. I'm going to go ahead and dump that out. And I'm going to go continue filling that. So we've already gotten 2,000 milliliters so far. Put in 100, get out 2,000, not too bad. So you're done. You're going to draw your box inside. You're going to put what you think is inside of here, and you're going to test it in your mind to make sure that you think it might work. Make sure the water doesn't can't come out of your system until after you add water. What does the water do? How does it trigger it? I guess I've already given you the secret away. There's got to be water inside of here already. There is some trick to it, yes. We're not bending the rules of reality or physics or anything like that. I mean, there's no magic or miracles or anything overly complicated. And so, simplest idea would be that there's got to be water inside. So figure out a way to work that extra water inside of here, because we're up to almost 30 times as much water in here. Is that right? Yeah. Than what we put in. So there's got to be enough to hold close to a gallon of water inside in there. And then how does the water being poured in trigger that to be released? Don't have it be able to come out beforehand. If you want a C on this paper, okay, just draw your box with what you think is happening inside. Make sure that you don't label anything. Make sure that when I look at your picture, I have questions about what's on there and what objects are in there. Make sure you don't explain how it works off to the outside. That's how you get a C. Just minimal work there. If you want to be, label some stuff. Say this is a marble, or this is a stick, or this is the bucket with some water in it. This is water inside of here. And then explain out to the side, step number 1, water goes in the top. Step number 2, then what happens? Explain the steps on there of how the water makes it through and how it triggers and makes that go. If you want that's if you want a B. If you want an A, make it look pretty. Add some color, make sure it's polished, make sure it looks pretty good, and make sure it makes sense. A good idea with explanation and details and color will get you an A. If you want an A++, maybe 100%, maybe over 100%, come up with 2 or 3 ideas that would work and do those as well. So there's some different levels for you. You may say, I just want to shoot for the C, and I guess that's okay if you're a C student. But I know all of you want to do the best you can. And so, we're still going. I'm trying to waste some time here while this is filling up. Still going. You can tell that the water isn't coming out as fast as it was at the beginning. So it's slowing down just a little bit, and I think I don't want to touch the box, but it's still dribbling in there. Hopefully you got your piece of paper, and you can start working on that idea now. Make sure your name is on your paper so I can give you credit for that. And then later on in class, we'll look at those ideas, and I'll put you in a group, and you can visit with that group, and they can kind of point out some strengths and weaknesses of your design. Now, just to give you a heads up, I have it set up a certain way inside this box, but I have seen over the years several different ideas that would probably work. If I had taken that student's idea and set up just that way, it would work just the way that you saw it happen today. So the goal today is not to get what's inside that box. The goal today is to think like a scientist. The goal today is, can you problem solve and think, how can I get my box, my design to do what we just saw in there? Here's an example. Here's a parent, concerned parent, who wants help for their kid. Let's see. Drought Stopper. I have to build a working model of a drought stopper for my daughter's 5th grade class. They have to build the model, not just a picture. I cannot find out what or how to build one from the web so far. Help, the lost daddy. Pictures and drawings of how it works would be great. Once I know how it is, what it is, and how it's used, I can build it. Thanks. Now, getting ready to stop here. So, we don't need to Google anything. This is a thinking activity. I'm not concerned that you get the right answer. There's several different ways that could work. I want you to be thinking and problem solving and testing and seeing if your design will work, and then have an opportunity later to meet with other kids, students in the classroom, other scientists, to see if we can get them working. Looks like it's almost getting ready to stop, and it's done. Okay, so it looks like we end up with just a little over a liter here. Just a little over a liter. So we put in 100 milliliters, and we get out an additional 3,000. That's pretty incredible. So we know that there's no bending of physics or rules or magic or miracles going on. So what design can you come up with that will fit inside this box that would make it do the same thing? What I'm concerned about is, are you thinking? Are you taking good notes? Are you making it clear for the people who are going to be looking at this as well. Good luck.